Welcome to the stream. This is a stream about SpiderMonkey, and we're going to talk about how to implement things in SpiderMonkey, how to fix existing issues, and learn about the spec through the implementation, through the tests, and everything. Okay, we were looking at this test 2 weeks ago, and we were talking about how do we fix it? What's the problem? We discussed how this expression here is, one second, a way to express a uniform API surface of the language, and that in the current SpiderMonkey implementation, we have an inconsistency between how this part of the expression evaluates alone compared to when we evaluate it with a pre-increment, prefix increment. And we fixed it. We got it to pass tests. We put it into a reasonable form, and I pushed a patch of it. So here's the patch. It's on Fabricator. Fabricator is the service that we use in Mozilla to handle patches and merge things into our main tree. And I had someone take a look at it, and just to review what we changed, we took away this piece of code that was, okay, stepping back. I planned out this entire thing and then I forgot what I was going to do. First thing we did is that we looked at the spec, and we discovered in the spec that we were supposed to do something other than what we were doing in the code. What we were doing in the code is this instruction here, where we check the base value was being run in step 2, one step before getting the value. And that's what we changed. So here we are removing that code from its position, and then we implement it here inside of emit_get. We just moved it, and there was an important thing that we needed to keep in mind, which is that JSOP swap needed to be used because the bytecode is a stack. I don't have the toilet paper today because we ran out. We had to swap objects, we had to swap elements on the stack in order to access the correct object, and then swap it back to get things back in order. Right. Does anybody have any questions about what we did in the last stream that I can clarify, or if somebody's new and is a little lost, let me know. I'll show what it looks like just in the terminal because it's easier to see. Here we have the check for if it's the increment or decrement, and all of the work that we needed to do. And I also have, I think I actually need to build this. I don't think I built this yet, so. Hello, hi everybody. No questions? Everybody's totally with me, despite my bad introduction. Also, still need to clone the, yeah. This is the third and the final planned stream so far, but it looks like we've got some really good feedback so far. So I think we'll probably continue with it. I think it's been really great. All right, it looks like nobody's got questions, so let's take a look at what we do next. Now, one place I want to start is actually with the tests. And that is, I want to open a new thing, and somewhere deep in my history, I have this list of tests that we had. And actually, we can see it in the patch. I removed a series of tests. So these are all now working. Magic, fantastic. We fixed not one test, we fixed 8 tests by making that change. And that's going to be a bit of a theme as we're fixing things. Okay, and post fix. And we've got all of these other tests in there. So this isn't, the issue itself actually, if I show you these further, the issue, which is this one right here, has a lot of bugs, a lot of tests failing in relation to it. And it also says it probably doesn't cover all of the spec violations. Okay. So let's take a look at that bug and dig into it a little bit. Actually, I've already got it open. And you can see my patch is here. So if you want to find it, I posted it in the Twitter link. But you can look at the entire conversation, what's been going on right here. And it's 4 years old, this bug. It's been here for a while. It's been posted by someone named Bytecode on the internet. And he's given us a pretty detailed bug report that includes this. That includes this particular test. Another person came along and found the regression range, and we also now have a bug list to work with. And then 4 years later, we come along all together and we post a patch to fix this. Well, what's going to happen when we post this patch? Obviously, everything's going to be great and shining and happiness everywhere. Well, we get a bit of an issue here. So Andrei Bargul, the author of the original test, has posted and said that there's an open spec issue about this type of bug. The image is frozen. I'm sorry that there keep to be issues with the stream. I actually changed the setup of the stream, so hopefully it's happening less often. Yeah, let me know if more people are having issues with the stream or the sound. I reconfigured my setup. Okay, cool. So fewer people are having problems. Yes, Backup is Kevin Gibbons from TC39, and we'll be seeing more of him in a second. Okay, so coming back to the issue that was posted in response to my patch. There's an open spec issue for this type of bug. So we're talking about a class of bugs. Basically, we never invested the time to implement the exact spec algorithms because it leads to regressions, bloats the bytecode, and it has worse error messages. Those are two problems we're going to be focusing on. And the spec was never changed to follow the implementations because it requires reworking the reference type. Let's understand that a little bit better. Let's understand what that really means and see how that issue was described on the specification itself. And ding. This one I didn't have open. So this is from 2016, and it's actually echoing an even older bug on a now non-existent repository or website. ECMAScript.org no longer exists, but we had a lot of bugs there and things were commented that have partially been migrated, partially not. So tests added to test 262 have revealed long-standing deviations between the specification and the reference type and actual implementation reality. Whether the specification should be changed to reflect the implementation reality, or alternatively, implementers should comply with the specified behavior should be discussed. So this is another layer of issue that we're looking at. So our first layer of issues is the fix that we implemented has two problems. One of them, we are bloating the bytecode, and it's true, we bloat the bytecode. Let's take a look at it. Oh, actually it's here. We added like 2 new things to the bytecode. Every single time that we do this kind of an operation, there's 2 new things that need to be done. So it's really not that ideal. And we'll look at the other problem which was raised by Andrei Bargul, which was that the error messages are now worse. Those are both issues that we want to consider before we go ahead and say that we're going to pursue this fix. Okay, coming back to the issue about the spec. So we have our implementation issue, but now there's an issue with the spec. Actually, most implementations didn't implement this correctly. So let's read a little bit more and understand this a bit further. We have, in 2016, there is no resolution and further deviations continue to exist. I think if we want to change this, it should be a full proposal because it's a core part of the semantics. Like we're talking about changing the reference type. I think that's what it was. Yes. We would need to change the reference type and how it's implemented. So it's difficult. The difficult part in my mind is that the current spec seems correct, and the biggest argument in favor of fixing this problem is that it's hard for implementers to do so. Maybe that's enough. Maybe the fact that it's difficult for implementers to do something is grounds for changing the specification. Something that gets discussed in committee sometimes. And we talked about how implementer concerns can be brought up in our last stream, which was on Tuesday. But yeah, I'm going to check if there's any questions. Okay, looks good. Yes, so someone asks, does TC39 have some Discord server or similar stuff for everyone who's not a TC39 member? That is true, yes, we do, and DevSnack answered, and it's the answer is going to go on the screen right now. Our group is called esdiscourse.group. You can join and you can ask any kind of questions there. We have a special section here for I have questions. You want to learn something, you're not so sure about something, go ahead and post an issue there and someone will get back to you. Maybe you have an idea, post an idea into the ideas tag. Or if you want to discuss an existing proposal, but the thing that you want to discuss doesn't fit as an issue, you can also discuss it here. Thank you, DevSnack, for that. Okay, coming back to the issue. Okay, so now we start to dig into the issue a little bit more here. The issue being the deviation of implementations from the specification, and that the specification has certain has certain challenges to it that make it easier to write as spec text, but difficult to implement. And now let's understand how different implementations are implementing different pieces of code. Okay, just taking a look. Someone asks, is this stream about specific compilers or a compiler, or about any compiler and related things in general? This stream is about the SpiderMonkey compiler, but it has quite a bit of additive material about how the specification works and impacts that compiler and our implementation. Okay, so here we have a reference test where Bytecode has gone through and listed what the result of hits will be. Now, this is here's the example code, and if you read this through the spec text, you will come to the conclusion that hits should be 1. And looking at the implementation, he has here all of the different implementations and how they would evaluate that. And they evaluate differently. So at this time, this is again 2016 in the past, SpiderMonkey had 1, V8 had 2, WebKit core had 2, Chakra core had 2, etc. So there was a deviation between the different implementers. And the same for this next example, we see a difference between the implementations and from the specification. There's more discussion about this. There's an expression of a preference for the semantics in the spec. And actually, this is the bug that we were fixing, so surely it should not call F twice, and we looked at that earlier. And there is lots of bits and pieces in this issue, and it's interesting because you can see how people reason through a problem like this. But let's talk a little bit. About these results that we're getting here. Like, it must be really time-consuming to go and get the data from all of these engines. Like, let's say you're curious about how a given piece of code behaves on different engines. You would have to go and like open Chrome, test it on there, open Firefox, test it on there. There must be a better way, right? We actually have tooling for that, and I'm going to show you that tooling so that you can play around with it yourself and have some fun with multiple engines at the same time, because that's obviously fun, and I find that fun. I think it's awesome. So let's do that. Okay, actually, I want to show you first the tool we're going to use. So this is by Brian Terrelson. It's called ESHost CLI. And this is a tool for running the same piece of code on a bunch of different engines. And there's some install instructions here. You can pretty much copy-paste this install instructions directly into your terminal and it'll run and it'll practically work. There's a few things that don't quite work, but for the most part they will. And you'll notice here that we're listing out multiple engines, like Engine 262, which is a really great project. done by someone who like went and implemented the JavaScript spec in JavaScript, like very close to the way that it's written in the specification. Different implementations have different goals, and this one is really about implementing it as it is, like almost as a reference implementation. If you want to learn more and like see something that really closely follows the spec, that's a great thing to look at. Hermes is the Facebook engine, I think. JavaScript Core is, forgetting the name of the company, Safari. QuickJS, SpiderMonkey V8, XS is a really tiny JavaScript engine, which is also very interesting to look at. Okay, and you can basically just download this. The only caution that I have is that I tried to get QuickJS working. It's not working for me right now, so you might have some trouble with it as well. Basically just remove this line and it should work as is in this README. And the other thing is you might need to remove a semicolon here and there. Okay, let's take a look at running some of the examples that were in the issue to understand how they behave today, because we were looking at stuff from 2016, and let's see how it looks today. Sorry, I forgot Safari. The name just disappeared for me. Okay, what was I gonna do? Now I forgot what I was doing. Right, okay. Let's look at the instructions about how to run this thing. So we have some examples, and you can see the output here. I'm just gonna run it. It's gonna be fine. I'll run it. I will run an earlier one. Yeah. How about I run something really simple from the issue itself? Let's find a nice little thing. Let's actually test this first one here. I'm gonna grab that, and then I'm gonna drop it in here. That should work. There we go. And we've got the printout from all of the engines. So this might be a little bit hard to look at. Someone asks, what is ESHost? ESHost is a project made by Brian Terrelson. Oh, that's not the right one. Brian Terrelson used to be the editor of TC39, and now he's a current chair, one of the co-chairs. And what it is it's a tool. There are two pieces to it. There's a CLI tool, and then there's the original repository. They're both hosted on his GitHub. So there's ESHost. It's a uniform wrapper around a multitude of ECMAScript hosts. And then you can use the CLI, which is pretty user-friendly if you want to learn more about different hosts and how they react to certain pieces of code. Okay, so here we have a printout of like this piece of code, the specific piece of code, with hits 0, object is equal to an object literal with a key p, 0, yada, yada, yada. Not actually the example we're going to be looking at, but we're just looking at differences between engines in the present compared to the past. And yeah, this is a little hard to look at because we see a whole bunch of things and it's hard to see what's happening. So we can do this instead. By adding a T, it organizes it in a table. And I think there was another command I'm forgetting right now. Let me see if I can find it. I think it's I. No, that's not it. I think I want maybe tags. Nope. Oh no, I broke everything. Let's do this. There we go. That's easier to look at. We don't see like duplicates. We just see what's different between the engines that output 2. Like, what's the difference between engines? Chakra, Hermes, JavaScript Core, etc. to V8, they all output 2, while Engine 262, Moddable, SpiderMonkey, they all output 1, which is what's the expected output for this thing. Okay. Oh, question about the props. So the first stream that I did, well, actually, these are some of the props. My uniform API across the different implementation props. And I also had toilet paper last time, but I don't have any toilet paper now. So I'll find something else to do for the props. Okay. So print, I think it's, in this case, it's just something that's being used for this project. Like different projects implement different specific APIs, and print is being used here. It's not coming from SpiderMonkey, but SpiderMonkey does have it. I don't think it's not a standard thing, if I remember correctly. But they must all implement print, if that worked. So, no idea. Right. Okay, so now we've seen one example. But what about our example? Oh, print is required for test 262. Thank you, DevSnack. And yeah, this is also, this ES host, I think, is also used by test 262. So we're using the thing that's underneath test 262. Okay, but coming back to our original issue, we're getting a little bit sidetracked because I wanted to take us on this little tour. Let's talk again about this problem, this issue that we're trying to solve, which is this, if we evaluate this by itself, it's different than if we evaluate this together. So let's look at that. I prepared some examples, and I think I have it as case 1. And here, it's basically the same error, the same setup, but I'm catching the error and printing it so that we can look at it and it looks pretty and all that kind of stuff. Right. So let's run it, and I can do ES host. I even have it right here. Okay, here we go. All of the engines agree about what this should be. It should be hello world, except for SpiderMonkey, which is base is null. So we have a bit of an issue. We should probably fix that. So there's, for this part of the problem, there's pretty good conformance across the different implementations. But it's interesting to see this stuff, so. Right. We won't be looking at a solution to this spec issue because the way in which it's implemented on SpiderMonkey, first of all, we're the only engine that's not conforming to the spec right now. And the concerns that we have about bytecode bloat and other things aren't consistent across other engines. We are using a different implementation mechanism for this stuff than, for example, JSC or JavaScript Core, which is, so we're using a stack, whereas they're using registers. So that's pretty fundamental difference. They aren't affected by bytecode bloat where we are. Okay. So. Anything interesting from here? I don't think so. I think we've had enough about this. About this issue. I'm going to move back to the fix and broader concerns that we have about the fix. Okay. Are there any, also ask any questions during the stream and I'll be responding to them, or there are several people in the chat who might be able to respond better than I can. For example, my colleagues are in the chat watching, and they have a lot of experience. There are also people who are from TC39 in the chat, and they also have a ton of experience, so please feel free to ask any questions, and people will get to it, or I will get to it and answer it myself. Okay, so what was I doing here? How do I make this clear? Okay, let's come back to this problem of this bug. This is a lot of things that we didn't fix with our last implementation. I'm going to ignore the bytecode bloat issue right now. I'm going to look at the fact that this is a bigger problem than what we solved last time. And then we're going to come to the bytecode bloat. So what I want to be able to do is I want to say that all of these tests, I want to see what happens if we try to fix them all together. So I just removed the skip behind all of those tests. They're all going to disappear. So, and how are we going to fix that? I'm wondering, does anybody have an idea about what we would need to do to fix it? Now, I'm going to point out a couple of features. This issue with, someone asks, did you reproduce this issue with the GraalVM.js implementation? That's a really good question. You know what? I don't think that GraalVM is currently in test 262, are they? They're not. You know what? That should definitely be in the test 262 and in the ES hosts repository. So I think we should probably open an issue for that. Well, why don't I do it right now? That's a good idea. Let's see if anybody's opened an issue for supporting. Let's do it right now. Is this the right spot? This is, yeah, here we have Graal.js. Yes, it is supported. It is supported, and I didn't download it, but I can do that for the next stream if you're interested. I thought it wasn't supported because it wasn't in the setup that I had, but it is supported. So we don't have to do anything, and that's pretty cool. I didn't know it was in there. So, okay. And DevSnack is giving some really good information about how to get it in your installation if you want to try running it against the Graal.js implementation as well. Okay, so coming back to the problem we're looking at, we solved a small piece of the problem. We solved the issue for increment and decrement, but we didn't solve it for everything else. And everything else includes regular assignments, compound assignments, and I'm actually going to open a thing. So it's not solved is a regular assignment. Also not solved is a compound assignment. So neither of these are solved, and that's what we want to look at now, because that's part of the larger bug that's our concern here. Okay. So, I'll just say it out loud. Someone made a comment about my appearance and it threw me off. This is a professional stream, so please let's keep it to tech. Okay, cool. So here we have the bugs, and everything is within those two categories. Also logical assignment. Okay. Now, if we look at this, implementation that we have currently, it's actually restricted to just increment and decrement. We also have compound assignment here. So, in order to fix that, what I'm going to do is I'm just going to, you know, for now, I don't know if this is going to be the full fix, but this is what we can do for now. I'm just going to throw this in here. And then I'm going to do a fuzzy check against the tests that we have. Okay. So it would be really annoying to run this manually. And what's great about the SpiderMonkey test runner is we don't have to directly spell out all of these tests. I see a question. Print-in browsers are the printer print API? Huh. Good question. I'm not sure. DevSnack has an answer. Great. Okay. So here I have my build. And actually I want to go to actually I can just go to central. And So I can just, I clicked too fast there. Uh-oh. Okay. I clicked a little too fast, but what I did is I ran mock JS tests and then the directory of my shell, and then a subset of the test. And what that does is it'll run all of the tests that match that description, and that's what it's doing right now. So we're actually getting a whole pile of tests here. And I think it's going to fail with 33 of the tests are going to fail because I haven't built with the fix that I just showed you. So while this is running, I'm happy to chat with people. Will I talk about SpiderMonkey baseline JIT in the future? I hope so. I'm learning about it myself. So the baseline JIT is maintained and run, developed by, well, from my perspective, in large part by Jan de Much, who's been helping me with this bug. And I think we will actually be looking at the JITs with this bug because part of the solution here is going to be introducing a new opcode, which we'll do probably in the next episode. And that will need to be optimized through the JITs. So SpiderMonkey has, I guess, we have one optimizing compiler, which is IonMonkey. And then we've got a few other things in between. So we've got baseline interpreter, which uses similar information as the baseline JIT. Then we've got the baseline JIT. And then if I remember correctly, we go into two tiers of IonMonkey. And I think Ian is in the chat and he would have a better answer for that. But yes, the tests do run concurrently. So when I actually ran into this issue because I was trying to track test failures in another project, and I didn't realize that the tests were running concurrently, but they are. But you can also limit the number of workers that are running the tests. Okay, here we have 33 regressions, exactly as expected. So we have to build this just to show the change again. So the change that we did is we added this is compound assignment. That's going to solve a subset of the problems. And I need to build, not mock, max. Okay, cool, so that's building. And someone asked a really exciting question, which is, has SpiderMonkey been ported to Rust yet? No. But we do have a really, really cool project that you might have heard about, which is kind of in Rust. And it's not fully mature yet, but we are trying to replace the C++ front end, which we're currently looking at in this series, with a Rust front end. And ideally, if everything goes well, in a few iterations of this series, we'll actually switch to looking at the Rust front end and how to implement stuff on that Rust front end. In case you're curious, I'll show you what it is. We're going to be trying to make it easier for contributors to do stuff and all that. Okay. So it has a lot of names. One of them is JAsparagus because it's a JavaScript parser. Generator, JAsparagus, but its official name is SmooshMonkey, and you'll see a lot of references to Smoosh. Here's the main page. It's a JavaScript parser written in Rust. It's really cool. We're going to be doing blog posts and things like this about it. If you want to learn more, we have a chat, and you can also get involved. We're going to try and get some more beginner bugs for this in the coming weeks. Hopefully soon we'll have it in a good place for contributors. It's a little hard to build right now, but yeah. Okay. Did it build? It built! Yay! Okay, so let's rerun those tests. Oh. Oh, no! Okay, there we go. Okay. I'm now learning Rust. Oh, wait, there's another question. It would be very helpful helpful if you talk maybe in the future about code generation trade-offs between performance and security from a web browser engine perspective. I would love to know more about that question. Like, what specifically are you interested about? Oh, I guess you mean generating code that is fast versus correct. So if you can detail that question a little bit more, then I'd love to dig into it. I won't be the person who has the answers for that, but I can forward them and come back with an answer for that. The next question is, I am learning Rust nowadays. Is there any scope to dig in or any other engine? So there are a couple of engines written, there are a couple of parsers and interpreters written in Rust already for JavaScript. I think one of them is called Boa. So in addition to our project. This is a project from Jason Williams, who's also a delegate at TC39. It's an embeddable experimental JavaScript engine written in Rust. This is one that I think is accessible for people, and it's really a hobby project, so there's not as many constraints about how things are implemented. There's also our project, which is the JAsparagus project. And there are others that I can't remember off the top of my head. That's the one that kind of comes to me like immediately. Yeah. Just a second, reading this. Okay. Right, so the JITs at the moment, there's no plan to do them in Rust. They are being developed, they're being actively developed, and there's currently work being done in C++. And am I familiar with the Canvas API implementation? I'm not. I don't know very much about the Canvas API implementation, but I can find out. I should be taking notes about things to find out. How about I do that? So, notes about things to learn about. And the first question was security and performance trade-offs for browsers. And the other question was about the Canvas API. Cool. And cool, okay, so the test's finished running. We have 11 regressions, down from 33. And what's important is that there's a different kind of error here. Previously, I'm going to scroll up. This is going to be a lot of scrolling. Before the build. I should have shown this earlier. I forgot. Oh no, I ran out of memory. Okay, so previously there was a different type of error, and I'll show you what that was. And now there's this new error, which is reference error assignment to undeclared X variable. Let's take a look at that test and see how it's different from the tests that now pass. Okay. My terminal is a little slow. Okay, so here, what this test is doing, it's also failing, but it's doing something pretty different. We are defining a property on the this object, so the global this object, I think it would be in this case, and it's X, and as soon as we try to get it, we delete it. And here we are doing an assignment to it. And then we're checking if that X is present, if the X has been assigned or not. And that's actually failing, and it should be passing. So this is really specific, and we're going to have to take a look at that later on. This is another bug that we've got listed in our list of bugs that we're going to fix. But for now, this bug is going to be out of scope, and we are going to move these failures into another space so that we can deal with them in isolation. However, the bugs that are now fixed, for example, A53, for example, this one is now fixed, right? Oh no, it's not. I have an example. Oh, you know what? I'll make this easier for all of us to look at because this is awful to look at. And we have 3 tests that were failing before, these 3 tests that are logical assignment tests that should all be fixed by our fix. So I'm going to run those tests instead. Here we are doing a fuzzy thing. This shouldn't take as long because it is a smaller set of tests. Just taking a look at the chat. Okay, so we have a first timer, and Ian gave a really great description. So what are we doing here? We are fixing bugs. Well, we are fixing a very specific type of bug in SpiderMonkey, which is a web compatibility bug. And we're using the JavaScript conformance test suite, the test 262 test suite, in order to determine where we're not conformant with the spec and other browsers and implementations. Okay, so the tests have passed, all of them, which means that those 3 tests I showed you earlier are actually passing. That's exciting. And let's take a look at the what kind of tests are now passing. Okay. So this is the deleting the X we're not going to deal with because that's going to be a different story. Oh. Yeah. Takes a while to open. Okay. So now we have this, and what we see is something that looks really similar to what we just fixed. This is fantastic. Like, we fixed an entire class of bugs just with adding a little bit of code and understanding the specification and what the specification needed us to do. But let's take another look at what we've done and what the specification tells us to do. Okay. So in the specification, where are we? We are in property accessors. So this is whenever a property is being accessed. And at the moment, we were just looking at property assignment in 2 specific ways. One of them is increment and decrement. The other one is compound assignment. So we take the value that was already there and we add whatever is on the right-hand side to it, or we do some other kind of operation. It's as a shorthand. But this is supposed to be valid for any property access. Now, we don't necessarily want to do this for everything because it can actually make the engine kind of slow. And in a sense, maybe being incorrect is better. That's a little bit of a weird thing, but like maybe it's not worth solving this bug. Maybe it is worth solving this bug. What's the cost of solving this bug, right? And the other thing is this change is something that's going to be changing like the way in which property access works throughout the engine, because the spec says that this should work the same way regardless of if you're doing an increment or a decrement, a compound assignment, or a regular assignment. So that means that there might actually be pretty significant downsides to making this fix. For example, and actually let's take a look at the comment that was made on the bug. The bloat of bytecode, like we look at the original bytecode, which Andre posted for us, and we can take a look at that ourselves. For those of you who haven't been in the stream last time, I showed how you could do this. So I'll just show it again. I think it was called, was it called foo? I'll just take a look at the chat while that's loading. I'm so happy that Ian is in these streams. He gives such good answers. Okay, so here's the thing that I did last time. You'll notice that this is a simplified version of the bug that we're fixing. So we have the undefined base, and let's take another look at that bug. Here, what we're doing is base is undefined. The property throws a dummy error. This is a detail that we don't actually need to use for our minimal case. And then it does a prefix increment on the base prop thing. Going back to the test, the mini thing that I did, we have this interesting call that you don't see elsewhere to do disassembly. And that gives us the output of what the bytecode emitter is doing. So let's run this. And we can do that just by running our shell. Ooh. And here, what this spit out, like this massive thing that it spit out, this is the bytecode that's being generated in order to run the code that's been written in JavaScript. So if you're unfamiliar with how an interpreter or a compiler works, there are several steps. The first is Lexing tokenization, where you take the text, like as a text block, split it up, and identify tokens within the text. A token might be something like var, or an identifier name, or an equal sign. Those are all tokens. Then you build an AST that shows the structure of the text. AST stands for Abstract Syntax Tree. And if you're coming from a JavaScript background, what that is basically an object with keys. Well, it could be an object, it could be an array. There are different ways that you can do it. And yeah, it depends on how you want to implement it. That shows the structure of the code, of the syntax. And then the AST gets transformed into something that'll express the semantics. Now this can go direct. The AST can be directly interpreted, or you can use bytecode, which is what we do, and that can be interpreted by something else. So the bytecode helps us with the. I shouldn't read the chat while I'm talking. There are so many interesting questions. The bytecode is the thing that the interpreter runs, and the JITs run that, and etc. Okay, there's another question. SpiderMonkey internals. I'm curious about whether SpiderMonkey JIT is multi-threaded engine. Ian has a great answer to that. JavaScript as a language is single-threaded, but it is concurrent. So you can, and Ian is giving I'm going to let Ian answer this, and then I'll read it out for whoever gets the video and not the chat. Is it wrong to say that JavaScript is basically C++? I think it would be wrong to say that it's basically C++. They have some pretty fundamental differences. They are both languages of many competing desires. I think that they share. They're very commonly used, so they've had a lot of stuff that's been input from various parts of the world, and like different types of views on a language have been brought into JavaScript and also into C++. We recently saw lambdas being entered into C++, etc. Okay, so for those of you who didn't see the last stream, it is possible to use the disassembler to see the bytecode that's being output when we're running a piece of code. And the critical stuff here is, for example, what we have here from 25 to 35, we have an assignment to base, and we're assigning the value undefined to base, and then we set it. Here we are assigning to prop a lambda function. And then we continue on, and this is the piece of bytecode that we're looking into. The difference of having an interpreter or not having an interpreter. So an interpreter, how do I explain this? This is a good question. So I've thought of I don't know if this is a good description of the difference between an interpreter and a compiler. An interpreter will directly interpret the code and re-express it in another language. Like it'll run it in C++. And a compiler will teach that language to the machine. So it'll basically go all the way down into instructions. And the way that I think of it is like the difference between an interpreter and a compiler is an interpreter is everything you're doing, you're pushing it through Google Translate. And that means that you can have very fast feedback. Like you don't have to compile the entire thing and have an understanding of the whole thing. Whereas the compiler is you have to learn the language that you're speaking. That's how I would express it. Maybe someone else has a better idea. I didn't think of that question, so. Okay, so there's a question about OSR or JIT code when they're compiled. I don't know the answer to that question. I wish I did, but yeah. Sorry, I'm also learning, so we're all learning together. Okay, cool. So I just showed how to use disassembly. Is there a difference between... that's a good question also. Yes, there is a difference. I'm trying to think of how to express it. How about we do that, because we're running out of time, how about we do that as a dedicated thing and actually read the spec and find out what the difference between those two are. So I'm going to copy your comment. Stop it. Stop. Oh, I don't know how to use my mouse. And there we go. And we'll come back to it because that's an interesting question that we should dig into a little bit further, and I think it'll be a lot of fun. Okay. Where were we? So we've partially generalized the code that we wrote in the last session, but we haven't fully generalized it. There's one more, and it's the sticking point. It's the difficult one. Which is, so we fixed this, we can delete these lines, that's great. We've fixed a good portion of these. I'm going to replace these lines with the new failing tests, and we're going to treat the new problem altogether. So I'm going to move this down. Actually, I can probably even grab the failing tests from here. So here are new failing tests. Oops. My key bindings aren't working. And I'm confusing myself, so I'm just going to focus on what I was doing before. Okay, and then the last question that we have is about these 4 tests, which are around basic assignment. So I'm going to grab those, rerun the tests, same story as always. Okay. And what this is going to reveal is that we still have a hole in our implementation that we need to address. So I'm going to let the tests run while I do the work, because I checked this before. There were a few things that came up. Yes, SpiderMonkey generates both types of machine code. The bytecode I'm showing is internal representation. And the native code is compiled in a different step. So we have this, and we're running low on time, so I'm going to skip a little bit ahead, but the regular assignment doesn't flow through this path, and for reasons. So I'm going to grab the necessary code, and I'm going to dump it where it needs to go, which is prepare for right-hand assignment. So this is basically just the bit of code that takes care of getting the left-hand side of an expression ready to be assigned to. And maybe in the next stream we'll look at that in a little bit more detail, because this is going to be a problem. And it sets us up for the next stream, where we'll look at solving this fully. Okay, so this prepare right-hand side, I'm just going to do a little bit of pseudocode or a little bit of JS-ish stuff. The JS that we're inputting here looks like this, which you probably recognize from the work that we've been doing so far. And yeah, that's the whole thing. And what we're looking at is this bit. And this is being prepared for assignment. That's what's happening here. So that's what prepare for right-hand side, and the right-hand side is a 7. Okay. So we skipped a couple of steps, but that's fine. And what I'm doing is I'm adding a bit of code into this thing that checks if it's a simple assignment or a property assignment. Now, this will allow the last main test that we can fix pass, and I'll run the make just to show that. Okay, a couple of questions came in the meantime. Why does SpiderMonkey use stack-based VM? JSC has a register-based VM, yes, that's true. V8 also has registers, and registers run faster. These are all true. So actually, SpiderMonkey has both. It has a bytecode-based VM, a semi-bytecode register-based VM, and a register-based VM. I think that those are all there. I know for sure the second one is the case for the baseline JIT. And the reason why we have a stack-based VM is because it's easier to understand what's happening. So the bytecode is written in a way that is really easy to understand all of the steps that are happening. That's why it's the way that it is. And then once we start optimizing, we do other things. I think that's the reason. But if I'm wrong, Ian, please correct me. I don't want to tell people wrong things, but that was my impression about why we did that. Does anyone know what font this is? You know what? I used to know what font this is. I don't remember what font this is. I'll post it after we finish the stream. Okay. Let's rerun the test. Oh, cool. We have made our implementation so that there's only one failing test here now. And we can take a look at what that is to better understand why we're failing. That's always a good idea. Nope, that's going to fail. Yeah, Ian gave also a very good answer to that question. Okay, and look at this. We see something that we've seen before. This is about deleting X off of the global, and it's throwing an error. So it's the same type of error that we decided is going to be in a separate bug. We're going to deal with that later. We're focusing on something else for now. And that means that we can dig into this. And these 4 tests, the last 4 tests that were failing and still part of our original bug, we removed them. And we can grab this new test that's now failing, copy that, paste, and there we go. And what I'll do is I'll update all of these with script. Don't need those two. And then all of these are skipping. So I'm going to create a new bug for these, and we will continue addressing that original bug further in the next episode, which is going to focus on how to get this through the JITs and what that means. I was going to show you how this performs, because one of the questions, one of the deciding factors for this, there's two issues here in fixing this. One is the bytecode bloat. That's not great. This is going to impact a lot of JavaScript and is potentially going to make things slower. So I had a verification of if this made this slower. It makes it a bit slower. It's a micro benchmark that I wrote. This does become a tiny bit slower, but not significant enough that we shouldn't be correct. And then the second question is about error messages. And I'll very quickly show you the problem with error messages here. And here you'll notice that we now have a new failure in a separate place. We're no longer looking at the same tests we were looking at before. Now we're dealing with JIT tests. And I've got a test called expression autopsy. And there's a failure. And the failure looks really, really strange. It looks like this. It's got a UE and then a closing parenthesis, closing bracket, dot foo, expected accessing 0, dot foo. And in the next stream, we're going to look at why that's happening and what we would need to do to fix it. So I'm going to take another 5 minutes for questions, and then we're going to go just into chat, because I have a hard time talking for a long time. That's why these are an hour. So are there any questions that I can answer directly in the video? And then we'll go to chat. Actually, I'll open the thing so you can take a look at what we're dealing with. Really great question. What is JIT compiling and what are its alternatives? So JIT stands for just-in-time compiling. So JIT, just in time. There's also ahead of time compilation. That's the alternative. What just in time compilation means is that you have your program running on an interpreter. And the thing about interpreters is that they tend to be a little bit slow. So you can actually compile code to be a bit faster. There's often tiers in an engine. Compilation, however, takes time. So for example, you just want to run your JavaScript. And the interpreter is usually fast enough for that first run. But let's say you've got an infinite loop. Actually, I'll show a loop of what that looks like. So here's an example of something that's going to trigger the JITs as soon as it loads on the page, eventually. This is always much slower than when I run it without the streaming. And you'll see here that I'm running this function. Is that a million? Yes, I think that's a million. 10 million times. When you're running something so much, chances are you don't want it going through the interpreter. Actually, let's take a look at that. Because we can control whether or not we compile this with the interpreter, with the JIT or not. So what I'll do here is no baseline interpreter with. Actually, I'm going to change that benchmark because it'll take a really long time. Come on. So let's get rid of a few zeros, and then let's do this. The baseline interpreter is an interpreter that uses very similar information as the baseline JIT, and it's actually a bit faster than the regular interpreter. Benchmark. Okay, so this is going to show us what this code looks like, and it's going to be considerably slower than when I switch it over to IonMonkey, which is the higher tier of SpiderMonkey. Yes, we recently added a fourth tier, which is the baseline interpreter. And if you're running this, I just passed this argument here, no baseline interpreter. This pretty much turns off all of the JITs because it can't graduate into the higher tiers without the lower tiers. Now, I don't know if it's taking this long because of the streaming or because of the baseline interpreter. I don't know about, I guess it's llint, so I'm not sure. I'm not sure how much similarity it has, but yeah, Ian mentions is that the baseline interpreter is generated at runtime. I should have made it even shorter. I'm going to be here for a while, aren't I? So Mozilla team members also stream. There is another stream from Mike Conley, and he talks about what it's like to work on the front end in JS and C++. That's another stream. I think it's called The Joy of Programming. And there are other Mozillians who are starting to stream. For me, streaming is really new. I don't know what I'm doing, so sorry about all the technical difficulties. I wonder if this is going to, I'm going to open a separate thing and like see if, I don't know, I'll just let it do its thing. The other thing about doing benchmarks is you shouldn't be doing anything else when you do benchmarks. Oh, I know what I did wrong. There we go. That's much better. Okay, so that's without the baseline interpreter. I don't know if 10,000 is going to be enough to do it. I am eager. Should do it though. And okay, here we are. So we have no baseline interpreter takes, I think it's 500 milliseconds. And with Ion, with the JIT, it takes 9 milliseconds. Right, so sorry, it took me a little while to answer that last question about what's the difference between having just the interpreter and what happens when you have a compiler on the back of that. So I'm going to finish off the stream here. Let's continue chatting in the comments, and I'm going to be happy to answer any questions through text. And then we'll probably be back here next week on Friday. I need to figure out the schedule a little bit more. And yeah, next up is going to be implementing this as a bytecode to address the failure of the errors and other questions. That's it.